Example 1. A moving coil galvanometer of 300 ohm resistance gives a full-scale deflection, for 1 milliampere. Find the resistance. Find the resistance of the shunt. The resistance of the shunt that is required to convert the galvanometer into a 3 ampere ammeter. We have the galvanometer represented by capital letter G. To convert it to an ammeter, we have to connect the shunt in parallel with the coil of the galvanometer. The arrangement is shown. The current through the galvanometer at full-scale deflection is Ig, and the total current coming in is I. Current going to the shunt is Is. Then we have the resistance of the galvanometer as 300 ohms. 300 ohms. We have the shunt. We are looking for the value of the shunt. Since the shunt is in parallel with the coil of the galvanometer, then PD across the galvanometer is equal to PD across the shunt. To have the current flowing through the galvanometer times the resistance of the galvanometer equals to current going to the shunt times the resistance of the shunt. This, if we apply the values, we now find first the current going to the shunt. Total current I is 3 amperes. Then the current of the galvanometer from the question is 1 milliampere. Ig is 1 milliamps, which is 10 raised to power minus 3 amperes. The current going to the shunt is the total current minus the current going to the galvanometer. So the current of the shunt is 3 minus 0.001, which is 2.999 amperes. Therefore, IGRG is ISRS. We apply the values into this, and I have current of the galvanometer 0.001 times resistance of the galvanometer 300 is equal to the current of the shunt 2.999 times the resistance of the shunt. From this, we now have the value of the shunt as this multiplying this will give me 0.3 divided by 2.999, which is 0.1 ohms, or 1 ohm. That's the value of the shunt required to effect the conversion